Hello, it's good to see you again on NASENI Milestones. Thank you for joining us. For several weeks now, we have been showcasing activities of NASENI Research and Development Institutes across Nigeria. These institutes are indeed productive entities where science is translated into technology in order to primarily address human problems in other sectors of our national life, namely health, education, transportation, banking, industry, agriculture, environment, etc. The truth is that NASENI is structured in such a way that all its development institutes specialize in various aspects of technology development with a set target. For instance, the Advanced Manufacturing Technology Institute Jalingo, Taraba State, where we are focusing our attention for today. The institute is engaged in the development of advanced manufacturing technology, one of the cardinal steps in line with the mechatronics and related engineering for advanced technology in terms of cutting-edge equipment and the critical skills required to prefer direction in advanced manufacturing. In today's program, we'll be educating Nigerians on the abilities of the Institute's personnel with respect to their perception, imagination, and creativity, which form the basis for innovation that could lead to the production of capital goods and services at the research center. My name is Kierian Umeayo, and it's my pleasure to take you all the way to Jalingo, where some Nigerians are doing us proud in the provision of science and engineering infrastructure. Design and prototyping unit, essentially for the designing of product concepts, as the production process begins with prototyping and visual illustration of the concept prior to fabrication and other steps that lead to a finished product. Let's now bring in Engineer Theophilus Oloyede, head of the designing unit.
First of all, we have to do the CAD design as is obtainable here. Now, most of the machines, we ensure that we design them first before the actual production. Now on this, we have been able to produce the solar power rice milling machine. This is the solar powered rice milling machine. Now the solar power, we go into the CAD system. Now this is the machine itself, and we go to the wire frame of the machine, which exposes most of the parts, the hidden parts of the machine. As you can see on the body, we have the components. Each of the components are being designed and are tested. Now these components are in various forms. We have the blower, we have the discharge spot where you discharge the rice after milling and polishing. And we also have the polishing screen, which is embedded in the machine. It does most of the polishing and the screening of the rice. And it also has a frame, because this machine are enclosed in a frame. So we have the frame design, which we also do on the CAD system. And this is the frame. This is the milling and polishing screen. Now this is the rice discharge spots, and this is the frame on which that carries the machine itself. Now here is the hopper. The hopper is where the rice is being charged into the machine for further processes.
Fabrication is the process of constructing products by combining typically standardized parts using one or more processes. An example is the steel fabrication, the production of metal structures using range of processes including cutting, bending, machining, and assembling. We will hear more from Engineer Idris Ibrahim, especially on the digital and modeling aspect of his operational unit.
In this unit, we are using 3D printer to print a prototype, more especially those that come from our design and prototype unit. So we have different types of 3D printers here. We have the up-box 3D printer. This is the up-box 3D printer. We have the Minda, which is also a tabletop 3D printer. We have another one here, the SLA, stereolithography apparatus 3D printer. And we have the big one here, which is our industrial Postus 3D printer. This printer is industrial, is very fast. Materials that the 3D printer is. We have a support material here, and we have this cartridge. It will take to finish printing this now. So it is almost 1.5 hour, 1 hour 18 minutes remain now to finish printing this object. So as you can see, if you come here, you see the reality here. Yeah, so it is now adding some layer. The printing is layer by layer. It is now adding. After it finished this layer now, it will go to the next layer, and it will start printing everything on that layer. When it finishes, it will go down a little bit because this is a 3D printer. It's using X and Y axis. So the Y axis is the high. After it finishes printing that layer, then the Y-axis will go down a little bit, one layer down. Then it will print. When it finishes, then it will go to another one again till it finishes all the layers that it has already slashed. So what we used to put it on the side here. And it will come here. This is the extruder. You will see this is exactly what. So when it comes to extruder, this extruder, it has a heater and the nozzle head. So it will heat this material to 274 degrees. The thing will melt, then it will start dropping on layer by layer.
Robotics engineering and artificial intelligence are most sought after and fast-growing disciplines in the world today. And having considered these areas as synonymous with modern advanced manufacturing, NASENI created special unit for them at Advanced Manufacturing Technology Development Institute, Jalingo. Engineer Daria Yusuf Omar heads the unit.
These two are 6-axis industrial robots. And this is the robot we call the SCARA robot, which is the selective compliant assembly robot arm. We have other types of robot arms used in the industry, such as the Cartesian robot, which is also known as the gantry robot. We also have the parallel robot, which is also known as the Delta robot. But we are starting with these ones because they are some of the most basic robot arms you find in the industry. As you can see, this particular 6-axis robot, we acquire it for training purpose. It's for educational purpose. It has a payload of 1 kilogram, and it can be used to train people to study and to conduct research on basic robotic application such as pick and place, such as assembling, and other industrial applications that are well known. We use it to teach, to study robot programming, both offline and online robot programming. We also intend to make use of it to learn the teaching functions of the teach pendant of the robot, to learn robot kinematics, to study basic robot input-output. You know, the input-output is where we can actually connect some peripherals to the robot to make use of it. For example, here you can see that we are having a robot gripper, a pneumatic type of robot gripper, which is the suction cup, and it works based on the program that is sent to it. We have another gripper. There is also a pneumatic gripper. It's a mechanical robot gripper. All are used on this robot. And then we can integrate more peripherals, or which we call the end-of-arm tools. We can integrate with the robot and make use of them to carry out some industrial applications. Similarly to this robot arm, they are just the same type, but this one is more advanced than the other one, which is for educational purpose. This is actually an industrial robot arm that can be used for other industrial applications also, such as welding application, such as plasma cutting, and other application. All the applications that are found on this other robot arm can also be done here. So we acquired this one, though is a smaller one, is a lighter industrial robot for us to teach people and to research on it and to improve on our own operations. The SCARA robot is very popular in the industry, and we acquire it also so that we can train people and also conduct research on some industrial application of this robot arm, such as pick and place, screw driving, machine tending, and so on and so forth. In the unit, apart from the robot arms, we also have other facilities. Here with me are training kits for the programmable logic controllers. In the process automation lab, we can see that we have the programmable logic controller integrated in the process automation workstations. Here we bought the basic items that are needed for one to be trained to be able to develop technologies, industrial automation related technologies from the scratch and program it as required.
At the Machine and Fabrication Unit, it has always been a beehive of production activities which resulted in the manufacturing of agro-based machines such as maize thresher, interlocking, molding machine, rice thresher, gas-fired dryers, and many more. The unit is endowed with professional machinery specifically designed for advanced manufacturing. Engineer Dr. Kichuku Chijoke tells us more.
So this workshop is the machining and fabrication shop. Here is a computer numerical control machine which you can use to carry out rapid machining. It's an advanced machine. It has several advantages that over the conventional machines, such as repeatability. The same component that you produce, you can repeat it several times and you achieve the same surface finishing, the same quality. Now, here you have to feed a part program which has been debugged. And that part program, you can type manually, or if you have it in a card generated from a CAD software, that is computer-aided design software, you can feed it with a hard drive. There is a provision there that you use to feed it. And then you make sure that the workpiece and the two posts, the tool on the two posts, they are set in line with what you have written on the part program. Now, when that has been done and the program is checked or simulated, then you can dry run before you do your machining. This machine, like I said, has several advantages. It has greater manufacturing flexibility. It has higher repeatability, more than what you can achieve with the conventional machines. Here is a computer numerical control milling machine. It can be used to carry out machining of parts such as gears, whether it's bevel gear, whether it's spur gear, different types of drilling, complex drilling operations. So like you can see, there is a dedicated computer which you also feed the part program which has been debugged and simulated. So once the part program is right, then you can feed in and then set your workpiece and the the tool and carry out your machining. Like the lathe machine that I showed you, it has the same kind of advantages. Here is a tabletop CNC lathe machine that you use to train people before you go to the industrial CNC lathe, which I showed you before. A spot welding machine, you can use it to join metal plates or sheets of metal. Now, it works based on the principle of electrical resistance. When you put the two plates as shown, you find out that there will be a resistance to the flow of current between the two copper electrodes. That resistance will cause an increase in temperature on that spot, which will get to the point of the melting point of the metal, and then by application of pressure with the leg, the metal will fuse together. These are some of our products. This is a solar-powered mesh thresher. It can be used off-grid. You can use it in the market. You can use it at home to thresh your corn. Now, this one, the computer-aided design has been shown in the fact center. This is a solar-powered milling and polishing, rice milling and polishing machine. It can also be used off-grid. You can use it at home. You can use it in the farm. You can use it even in the market to carry out the milling of your rice paddy. These are interlocking bricks molding machines. You can use it to mold interlocking bricks. The machines there are smoke houses. They are powered by charcoal. You can use them to roast fish, meat, and any other food that can be roasted. A rice paddy dryer. After parboiling rice, you can use this machine to dry it to the required moisture content before milling. These are gas-fired dryers. They are to be used to dry fish and also vegetables. So they are undergoing construction.
Auto Machine Center and MPS workstations are integral part of Advanced Manufacturing Technology Development Institute, Jalingo. Here is the acting managing director of the institute, Engineer Christopher John Tanko.
So the mandate of Advanced Manufacturing Technology Development Institute is in sourcing, acquisition, development, and application of advanced manufacturing technologies for the production of components, machinery, and their production systems, and the transfer of same to the satellite industry. Now, you may wish to ask, what is advanced manufacturing technology? This is the method of production which incorporates highly automated and sophisticated computerized systems for design and operations. It aims at manufacturing high-quality products. If you go to our local industries here in Nigeria today, you will notice that basically all operations are done based on conventional methods of operation. But this is not so anymore in the more industrialized nations of the world, where manufacturing has evolved and the use of computer-controlled machines and the internet are developed. So the role of Advanced Manufacturing Development Institute here is therefore to promote the adoption of the technologies in the manufacturing sector of the Nigerian economy. So in Advanced Manufacturing Development Institute here, we have quite a few facilities in the research and development areas of our activities. These include the product design unit, the welding and fabrication where we develop products, the digital modeling fabrication unit, which you may call the 3D printing or additive manufacturing unit. We also have the robotics and artificial intelligence unit, and then finally the automation laboratory or training center. The automation laboratory is a world-class automation training center. We call it the Festo Authorized and Certified Training Center, FACT for short, where undergraduates, graduates, and even personnel of the industry are trained in process automation. Then the product design unit. This involve the use of computer system and then highly sophisticated software to convert the concepts or ideas into a workable design. Then the welding and fabrication unit is where the product development takes place. Here the product is developed based on the design that is already produced. The digital modeling and fabrication unit is a more recent form of fabrication, which, like I said, is the 3D printing or additive manufacturing. It involves the production of a component by producing it by the addition of layer upon layer of material until the component is formed. Then the robotics and artificial intelligence unit is where we have robot systems and other artificial intelligence systems that perform different functions, including educational and also manufacturing activities.
It is stunning, the achievements by the technical staff of the Advanced Manufacturing Technology Development Institute, Jalingo. They have indeed made substantial advancements in local production of agricultural machinery, industrial spare parts, deployment and development of artificial intelligence in the production process, and have shown high level of appreciation of advanced manufacturing system, which of course is enhanced by the adoption of emerging technologies. As you heard from one of the staff of the institute, a good number of technologies developed by the institute have been ceded to the private sector as part of commercialization process for the products. This is one great stride the management of the institute has recorded in recent times. The essence of this program is to sensitize Nigerians, especially those of them in the private sector perceived as the harbingers of homegrown technology, on the need to escalate the potentialities of this ideology championed by NASENI. Now time to bring in the Executive Vice Chairman of the National Agency for Science and Engineering Infrastructure, Engineer Professor M.S. Haruna.
This center started as Advanced Manufacturing Program. When advanced manufacturing was introduced to the world, we see what Japan are doing and what Chinese are following, what Singapore is trying. So NASENI, under the then leadership of Professor Adewoye, said NASENI has to establish a center that will be doing that. So it started as a program, just a program of learning, and it commenced here in the premises of the Taraba State Polytechnic and nurtured with time. And because of the success of the program, President Muhammadu Buhari, under my leadership, has approved and upgraded the center or program into a full-fledged institute of NASENI. Among the successful, the idea of this is that manufacturing worldwide is no longer done the way we do. It is computer aided. The design is computerized. The manufacturing is computerized. In fact, you do your program, develop computer program according to the machine or component you want to produce, and allow the computer aided manufacturing process to be producing the component for you. In fact, you can set it to work for 48 hours, 64 hours. You can set the machine and go home for weekend. When you come back, the products are being produced without variation because it's computerized, it's computer program. Now, here we have other equipment we have in other parts of NASENI, but here concentrate more on producing the 3D printing, additive manufacturing, because for each machine, after the design, you want to see the model of it through 3D printing before you commence production. Again, the 3D printing helps you to produce a prototype that you can mimic performance and decide virtually to test performance. Identify likely failure component or area, and after how many hours of operation, so that you take care of that before you produce the real machine by optimization. Now, this center has produced a lot of equipment, particularly in agri sector, food processing equipment, maize, rice processing machine. Now, let me say that one of the things that the institute excel in terms of revenue generation is in our fish drying. In this area, they do a lot of fish. There are a lot of fish farmers. They do fishing a lot, and their challenges is how to preserve this fish without spoiling. So our fish drying, the Taraba state government has bought hundreds and thousands and distributed it to farmers. It's helping them to dry their fish quickly and be able to sell to other parts of the country, in fact even to Cameroon. So the Taraba state government is happy with the performance of this institute here and gave us a permanent site, which we are now trying to move in. Construction work going on in this site. Let me commend the Taraba state government. The highest patronage of any state government NASENI has ever received is from Taraba state government. In fact, they are always waiting for more product to come out from NASENI. The indigenous of these states have benefited, particularly Taraba state government under the leadership of Darius Ishako. We have received enough patronage, and it has supported a lot of other innovative products to come out, as you can see. These machines are of international standard. They are not prototype, they are real machines. Individual, private sector, even factories processing rice have obtained different part of machines or new machines with their specification that they want social capacity, the way it will do this and that, in handling different aspects of rice processing, for boiling, drying, shelling, polishing, everything, and sorting, different components, and of course an integrated machine also available. So our food preservation equipment, fish dryers, crop drying and preservation equipment, as you can see, the brand originate from this institute. Additionally, this is also the center of excellence accredited by Festus in automation and mechatronics. And postgraduate students of Abubakar Tafawa Balewa University offering those courses used to spend semesters here for practical orientation, for experiment, and for hands-on, because we are in collaborating with them for a practically oriented master's degree program in which the practical training and exposure is provided by NASENI.
And that's our show for today. Thank you for watching. Hoping you will join us again next week for another session of Science and Technology Exhibition, courtesy of NASENI, the one-stop shop for science, technology, and innovation. I am Kierian Umeayo, and I believe in homegrown technology. Bye for now.